What if lasers could help us detect radiation faster, more accurately, and safely? Well, they're already doing it. When we think of lasers, we usually picture them cutting through metal or being used in sci-fi movies, but today, lasers are being used for something incredibly important: detecting radiation. This breakthrough technology is changing the way we keep our environment safe, and it could be the key to improving safety in industries like nuclear energy, medicine, and even the military. Let's take a look at how lasers are transforming the future of radioactive detection. Now, let's break it down. Traditional methods of radiation detection, like Geiger counters or scintillation detectors, have been the standard for a long time. These tools are great for measuring radiation, but they have their drawbacks. They can be slow, inaccurate, or not sensitive enough for certain situations. Laser-based radiation detection, on the other hand, works in a completely different way. Instead of relying on physical contact with the material, lasers use light to interact with substances and detect radiation. This process is called Raman spectroscopy. Here's how it works. A laser beam is directed at a material, and as the laser interacts with it, the material's atoms and molecules vibrate. The laser light that's scattered back can be analyzed to reveal detailed information about the material, including whether or not it's radioactive. One of the biggest benefits of this technology is that it's non-invasive. You don't need to touch or disturb the material to analyze it. That's a huge deal, especially in sensitive environments like nuclear plants or sites contaminated by radioactive materials. Instead of waiting for lab results, laser detectors can give real-time feedback on radiation levels, making the entire process faster and safer. Now, you might be wondering, what makes this so revolutionary? For starters, the speed and precision of lasers are game changers. Traditional detectors take time to process the radiation and may need to take samples or scan over large areas, which can take hours. Lasers, however, allow scientists and safety personnel to get results almost instantly. That's crucial in emergencies when every second counts. Lasers are also incredibly sensitive. Traditional radiation detectors can sometimes miss small amounts of radiation, especially if it's buried in large areas. But laser-based systems can detect even the smallest traces of radiation, something that's incredibly valuable in places like nuclear power plants, radiation cleanup zones, and nuclear disaster sites. These lasers can scan for radiation from a distance, helping keep personnel safe without them having to get close to potentially dangerous areas. Not only that, lasers are portable. Unlike big, bulky machines that require stationary setups, laser detection systems can be designed to fit in handheld devices. This opens up the possibility of real-time, on-the-go radiation monitoring. Imagine being able to monitor radiation levels at a nuclear power plant or even at a port where radioactive materials are shipped, without the need for large, expensive equipment. So how is this being used today? Well, in nuclear power plants, laser-based detectors are already being used to monitor radiation levels more effectively. These plants require constant radiation monitoring to ensure that everything stays within safe limits. Traditional methods can be slow, but lasers give real-time feedback, helping operators spot any issues as soon as they arise. Another area where lasers are making a huge impact is in environmental monitoring. After disasters like the Fukushima nuclear meltdown in Japan, radiation monitoring of the surrounding area was crucial. Lasers are being used to detect radiation in large, hard-to-reach areas, helping scientists and government agencies monitor contamination and respond quickly. The beauty of lasers is that they can be used remotely, so they're perfect for scanning entire landscapes without putting anyone in danger. Security and military use. Laser-based detection also has applications in military and security sectors. Security checkpoints, border crossings, and airports can use portable laser-based detectors to scan for radioactive materials, such as nuclear weapons or dirty bombs. The ability to detect radiation quickly and accurately can be the difference between preventing a disaster or not. Beyond industry and security, lasers are even playing a role in medical applications. Radioactive materials are sometimes used in medical treatments or diagnostic procedures, and lasers are now being used to ensure that these materials are safe to use and that they don't exceed radiation limits. The medical field can benefit from the precision and speed of laser-based systems, ensuring patients and healthcare workers are always safe. Of course, while this technology is groundbreaking, it's not perfect. One of the biggest challenges is that some types of radiation may not interact well with the lasers, meaning it's not effective for detecting every single form of radiation. Environmental factors like dust or smoke can also affect the accuracy of laser readings. However, as research continues, scientists are making breakthroughs to overcome these limitations, improving laser-based detection systems even further. As laser technology continues to evolve, the future of radiation detection looks incredibly promising. We could soon see laser-based systems become the standard in many industries, whether it's monitoring radiation in real time at nuclear power plants or scanning for dangerous radioactive materials at airports. These systems are becoming more sensitive, more portable, and easier to use. In conclusion, lasers are changing the way we think about radioactive detection. From nuclear power plants to environmental protection and security, lasers are making radiation detection faster, safer, and more accurate. This technology isn't just an innovation, it's the future of how we protect public health and the environment from the dangers of radiation. If you're fascinated by how lasers are transforming industries and keeping us safe, make sure to like, comment, and subscribe for more updates on cutting-edge technologies like this one.